when we think about the weather, we don't necessarily think that the temperature of the ocean might have much to do with that, but sea surface temperature is what you study. Tell me how that relates to the weather.
In order to have a good weather forecast, you need the boundary condition. In the case of the ocean, comes from sea surface temperature. So you need good sea surface temperature measurements in order to have a good forecast. Especially important in case of storms and cyclones. So you need especially sea surface temperature for that.
There are lots of different satellites measuring sea surface temperature. How do you deal with all those different data sets together?
At the Met Office, we have a system called OSTIA, which merges the information from satellites, either measuring in the infrared spectrum or the microwave spectrum, and creates a field sea surface temperature, and that is what is going on the numerical weather prediction model.
Your expertise is in measuring sea surface temperature from satellites, and that's important for lots of reasons, but tell me about how that relates to the atmosphere and the weather.
You need good sea surface temperature observations in order to have a good weather forecast. That's why you need satellite observations, because they provide you a global picture, not just point observation provided by in situ measurements.
And weather models, we are used to looking up into the atmosphere and seeing there's lots of detail. It's quite a small scale system relative to the size of the planet. And so satellite data over the ocean is the sort of thing that gives you enough coverage to pick up those details, because sea surface temperature varies quite a lot, even as a storm comes over the top.
Now we have sea surface observations down to with spatial resolution of 1 kilometer from some instruments. And this gives us a sufficient resolution to resolve all the physical phenomena that are useful for us.
So you've got a hugely detailed data set. And how do you sort of put all that, because there's obviously lots of different satellites measuring sea surface temperature, how do you put all that together into something you can use?
There are two types of satellite instruments that provide information about sea surface temperature. There are instruments working in the infrared spectrum and instruments working in the microwave spectrum. So what we are doing at the Met Office, we are blending these two types of information from the infrared and microwaves with in situ information coming from in situ measurements, and create something, a blended product, which then we are using every day to start our weather forecast.
We're thinking about storms, and so the winds can reach really high speeds in the middle of a storm. And that's the sort of, you can measure some wind data from satellites as well that feeds into weather models.
Yeah, there's another type of instrument called scatterometers, which provide the information about the ocean surface wind. This is very important for us because we use this information by assimilating into other, together with other information coming from satellites in our weather NWP model.
And so that's the sort of thing where you get a picture of a country, and you've got one here.
Here you have the observations from two satellite instruments called ASCAT on two different platforms for one specific day. And you can see the high speed here.
So these are little coloured, and the redder the colour, the faster the wind speed.
Exactly. And you have the direction. It goes like this.
So we've got a big rotating storm here, but this, even though this is wind speed, this is measured from a satellite. And this data isn't just useful now, so you can take this data and go, this is what the surface winds on the ocean are doing now. You can actually use that to improve your model predictions, and that's what the NWP is.
Satellite data are used in two ways. One way is for the weather forecast by assimilating in near real time, which is very important because you need your forecast to be available rather quick. You cannot wait for a long time. The other thing is in order to validate our model. This is very important because this is the way how you improve the model itself. The observations and the model should be close one to each other.
Surface winds are one very important input into a weather model, and sea surface temperature is another one. And you've got another graphic, I think, which shows sea surface temperature map. Now, tell me where this came from.
This is the blending product that we have at the office. which is, it gathers information from infrared instruments, satellite instruments, and microwave instruments, and this blending provides the best available information in order to start the weather forecast.
So you have lots of different satellites measuring in different ways, and you need a way of combining all that so that in your weather model, you just give your weather model one set, the best judgment on what the sea surface temperatures are.
Actually, different satellite instruments have different capabilities. For example, instruments working in the infrared provide very good sea surface retrievals, but at very high spatial resolution, but they work only at cloud-free conditions. If you have clouds, you cannot see the surface. That's where the microwave instruments come into play, because they are not affected by clouds. They are affected only by rain. So when you have the information from the microwaves, you blend it with the information coming from the infrared instruments, and that's, in this way, you have a better coverage of the Earth.
And that means that you can make these beautiful images like the one you show here that show all these details. So even though you could never have, the Earth would never be completely cloud-free for you to see this all with one type of satellite, with the infrared, you can put all these things together and get amazingly detailed images, and that improves your next weather forecast. And you can make comparisons. The data you've got here shows comparisons between the satellite observations and in situ data, and they match up.
The figure at the bottom shows the climate change as observed by the in situ observations. At the top, you can see in black the same thing. It's the in situ observations. And in red, you can see the observations from the satellites. And these two time series match very close together.
So even though you have two independent sets of measurements, it's worth having because it's an absolute check that if they're completely separate and they still come up with the same idea, that's a very powerful result.
Yeah, because no one at this point can deny what is happening. And at the same time, you can constrain more the uncertainties provided from each instrument, because every observation is not error-free.
The models also produce predictions for everywhere around the planet, and so you can check one against the other.
Actually, you are validating the outcomes from the climate models with information coming, especially from satellites and other observations.
And it's still improving, but it fits together pretty well at the moment.
That's why you are confident that climate change is not, it's a fact.
Lots of data to back up that conclusion.
Exactly.